So now let's talk about securing our microservices architecture. We have an API gateway in place, and we also have our services, the product service, order service, and the inventory services. So now what we want to do is we want to secure the services. As of now, you can access any of the services, any of the API endpoints without any authentication. We would like to introduce this authentication some kind of authentication mechanism to be able to access the service endpoints. Right? So for that, we are going to make use of an authorization server called as Keycloak. So using Keycloak, we can outsource our authentication and authorization related configurations to Keycloak, and we don't need to implement the authentication mechanism by hand in our microservices. So before going ahead and learning more about how to configure Keycloak in our project, I would like to recommend you to watch the Spring Security Auth to Keycloak video before going ahead, because I've explained all the OAuth 2 related concepts in that video, and I'm not going to repeat those concepts one more time. So now let's go ahead and install Keycloak in our machine. So for that, I opened the keycloak.org website, and in here I'm going to click on the section guides, and I'm going to, in the getting started section, I'm going to click on Docker. So we're going to mainly use a Docker image to run Keycloak. I'm not going to install this manually. So I'm just going to copy the docker run command here, and I'm going to open my IDE and open the terminal section. You can also run it on your terminal. I'm going to copy this command, docker run command, where we are running the Keycloak image on port 8080, and we are exposing the port 8080 from the container. And we are providing the environment variables, Keycloak admin user as admin, admin password as admin, followed by the image name. So this is the kwai.io Keycloak 18.0. This is the image name, and we are running on a dev profile. So that's why we have the start dev command here. Before running this command, I'm going to make a small change here. Keycloak is by default running on port 8080 inside the container. We want to access this Keycloak not on port 8080 on our host machine, but on a different port, because on port 8080 we have our API gateway running, right? So for this reason, I'm going to change the port 8080 to 8181 so that we can access the Keycloak on port 8181. And finally, I'm going to press enter. What this will do is it will first check whether the Keycloak image is present in your Docker registry or not. If not, it will first try to download the Docker image, and after that it will start the container. So once the Keycloak server is up and running, I'm going to open the browser and go to the URL http localhost 8181. So this will open Keycloak in our browser. So what I'm going to do is I'm going to click on the administration console link. This will take us to a login page. Here I'm going to type in the username and password we have provided while running the container. So that would be admin and admin. So here we are taken to the homepage of Keycloak, and in Keycloak we have some concept called as realm, where you can group all your clients, your OAuth clients, into a single logical entity called as a realm. So by default, Keycloak provides us a master realm, and we can also create our own realm. So what I'm going to do is I'm going to click on add realm, and I'm going to provide the realm name as Spring Boot Microservices realm, and I'm going to click on OK. And in this realm, we can create our clients, our OAuth 2 clients. So for that, I'm going to click on the clients section here, and I'm going to click on the create button. And in here, I'm going to provide client ID as Spring Cloud Client, and I'm going to click on Save. This will take us to a another screen where we have many fields, and in here we can configure what kind of client we can have. So by default, we can have different kinds of client. We can have a client, we can have a public client, we can have a confidential client, we can have a bearer only client. So for this project, we are going to select the confidential client, because as we are not going to make use of any websites to make the authentication. We are going to call the services through Postman client. So for that, it's enough to select the access type as confidential. Again, if you're feeling lost, have a look at my Spring Security Auth through Keycloak video. I've explained all these details: what is an access type, what is a client, what is a resource. All the concepts I've explained in that video in detail. So I've selected the access type as confidential, and here we have one option called as standard flow enable. I'm going to disable this option. I'm also going to disable the direct access granted enabled option, and I'm going to select the service accounts enabled option. So what this will do is it will enable the client credentials grant, and after enabling this, I'm just going to click on save. This will create a client secret. We can see the client secret by going to the credentials tab, and I can just copy this client secret, and I can come back to this client secret whenever I want to authenticate using this client secret. So after configuring Keycloak, what we have to do is we have to provide the URL of Keycloak in our API gateway. So for that, I'm going to go to the realm settings and click on OpenID configuration, and in here I'm going to copy the issuer ID, the object of type issuer. So this would be http localhost 8181/realms/Spring Boot microservices realm, right? I'm going to copy this URL, and I have to provide this URL inside our API gateway, because we are going to configure our API gateway to talk to the Keycloak server, right, as we have discussed before. So the next step is to configure our API gateway as a Spring Auth 2 resource server, and to also enable the Spring security so that we can configure the API gateway with Keycloak details. So for that, I'm going to open the pom.xml of my API gateway project, and just below the dependency of Spring Cloud Starter Netflix Eureka client, I'm going to add another dependency with the group ID as org spring framework.boot, and the artifact ID is going to be Spring Boot Starter Auth 2 resource server, and I'm going to remove the version tag because I want the same version as the parent. I'm going to copy this dependency one more time and change the artifact ID from Spring Boot Starter Auth 2 resource server to Spring Boot Starter security. And to enable IntelliJ to download the Maven dependencies, I'm going to click on this Maven icon, and once the dependencies are downloaded, you're all set to go ahead and configure the issuer URI in your API gateway application. So for that, I'm going to open source main resources application.properties file, and below the routes configuration, I'm going to type in spring.security auth 2 resource server.jwt.issuer URI. Right, and this issuer URI we have copied previously from the discovery document. So from this URL, this Spring Boot microservices realm well-known OpenID configuration, from there I'm just going to copy this issuer URI and I'm going to paste it in here. Just a small overview of how this will work. Spring Boot at the time of starting up the application will read the discovery document, and from this discovery document it will fetch all the endpoints to authorize to all the endpoints to do the authorization. So we have this authorization endpoint as Spring Boot microservices realm protocol OpenID connect auth, and we have a token endpoint where Spring Boot can make a call to this particular endpoint and verify whether a token is valid or not. So instead of configuring all these values in our application.properties, what we can do is we can just configure the issuer URI, and Spring Boot will do the work behind the scenes for us by reading the OpenID configuration and will receive all the information it needs. So the next thing I'm going to do is to create a security configuration class inside our API gateway. So I'm going to click on new class, and instead of creating a package, I will type in the package name as config.securityconfig. This is one of the shortcuts which was suggested to me by one of the subscribers. So thanks for the hint. Always nice to learn new shortcuts. So once we have created the security config class, I'm going to add the configuration annotation, and we want to enable the web security for the Webflux project, right? So for that, I'm going to type in enable Webflux security. So we have added enable Webflux security. This is because we are, if you remember, the API gateway, Spring Cloud Gateway project is based on Spring Webflux project, but not Spring Web MVC. So that's why we need the enable Webflux security annotation here. So the next thing I'm going to do is to create a bean inside the security configuration class called as Spring Security Filter Chain. So for that, I'm going to create a bean. And this bean is going to be of type Spring Security Web Filter Chain, and I'm going to type in Spring Security Filter Chain, and this method is going to take a method parameter of type server HTTP security, and inside this method now we have to configure the Webflux security details. So for that, I'm going to what I'm going to do is I'm going to first disable CSRF, because as we are only communicating through the REST API, through the Postman client. So I'm going to disable the CSRF here, and I'm going to add some exchange information here by typing authorize exchange. The second option where I can provide the exchange information. So I'm going to type in exchange and create a lambda, and in here I'm going to provide some more details of how Webflux should handle the security. So first of all, I'm going to add some path matchers here. So the path matchers is going to be for the path Eureka/star. So if you remember in the last tutorial, we have created for the route configuration for the Eureka discovery static resources. So whenever we are accessing the static resources, we want these calls to be not authenticated, right? So whenever we're retrieving the CSS and JavaScript files, we don't want to send some kind of token with it, right? So for that, we need to exclude this call from our security configuration. So that's why we are adding the path matchers to this is URL pattern, and we are going to permit all the calls to this URL pattern by typing .permit all. And after that, for any access, we want all the calls to be authenticated, right? For only the Eureka static resources, we want to permit all the calls, but any other calls, we want to make sure that those are authenticated, right? And after adding this information, we are also going to enable the resource server capabilities in our API gateway. So I'm going to type .auth2 resource server. And this resource server capabilities, we also need to enable the JSON Web Token capabilities. So for that, I'm going to type in server HTTP security .auth2 resource server spec. And in here, I'm going to access the method JWT from this class. So for that, I'm going to make use of Java 8 method reference. So I'm going to type 2 colons and then select the method JWT in here. And after that, I'm going to type in server HTTP security .build, so that this will create an object of type security web filter chain, because this is what we are expecting out of this method. And finally, I'm also going to add the return statement to this method. So now we have enabled security configuration in our API gateway, and we have also configured our API gateway to talk to the key cloak to authorization server. So as you may observe, this is very simple to configure the gateway to talk to the key cloak. Just need to add the dependency for the resource server, and you need to add a property file for the issuer URI, and everything will happen in the background. All our routes will be protected by Spring Security along with Keycloak. So let's test whether all the endpoints are really secured or not. So for that, I just restarted the API Gateway application. You also make sure to restart the application before the test. So I'm going to open the Postman client. I'm going to create a new tab, and I'm going to test whether the product service is still accessible or not. So I'm going to type in localhost 8080/API/order. So I'm going to select the HTTP method as get, and I'm going to click on the send button. And now you can see that we are getting a 401 unauthorized error, right? Because we didn't provide any any authentication details. So in this case, we have to provide a bearer token, a JWT token. So for that, what we have to do is we have to create the token. We have to request the token first of all from Keycloak by providing our credentials, and then we have to provide those credentials to the API gateway through the authorization header in the type of bearer scheme, right? So for that, I can click on the authorization tab, and in Postman we have a nice functionality to directly contact Keycloak and get the token. So for that, in the authorization type, I'm going to click on the drop down menu, and I'm going to select the type as Auth 2.0. And in here we can provide the information about our Keycloak client we have configured a while ago. So in the configurations options, we can provide a name, any name for the token you are going to create. The grant type I'm going to select as client credentials, because the client's credentials is the correct grant type whenever we want to have a machine-to-machine communication. And in the access token URL, we have to provide the endpoint of the token endpoint, which we have seen in the discovery document. So I'm going to open this one more time. And yeah, so if you remember, we are opened this OpenID configuration URL, and in here I'm just going to copy the value for the token endpoint, which is HTTP localhost 8181 /realms Spring Boot microservices realm /protocol /OpenID connect /token, right? So I'm going to just copy this and paste it in the section of access token URL. So I'm going to just paste it again, and the client ID, I'm going to provide it as the client ID we have created. And the client secret, I'm also going to provide the client secret, which I will get from my Keycloak realm. So let me open the Keycloak portal one more time. So I have to log into my Keycloak account one more time. So let me log in with the credentials admin. And now once I'm logged into the Keycloak, make sure that I'm in the microservices realm, Spring Boot microservices realm, which I've created before. And I'm going to click on clients and click on Spring Cloud Client. And here I'm going to open credentials, and then you just have to copy this secret what you have here, right? So I'm going to copy this secret and I'm going to paste it inside my client secret section. The scope, you can just leave it as it is, the default as OpenID and offline access. And the client authentication also you can leave it as send as basic auth header. And now after configuring all these details, you can click on get new access token. And you can see a message called as authentication complete. And once the authentication is completed, what Postman is going to do is going to request Keycloak for the access token. And here you can see this is the access token which we received as a response from Keycloak, right? So I can now click on use token, and this token will be used now whenever we are making a call to our microservices. So when I click on the send button, now you can see that we are getting 405 method not allowed error. Yeah, this is because I'm trying to access the order service, but I want to access the product service to get the product information. So let me change the URL and click on the send button one more time. And now you can see that we are getting the response back from our product service, and we are able to access this through our API gateway, right? So in this way we can secure our API gateway. So let's also do the test for the placing an order. So I'm going to change the URL as HTTP localhost 8080 API and order. I'm going to select the HTTP method as post. I'm going to create the same body as I've created before. And in the authorization tab, I'm going to select the token which I've created in this call, right? So for that, I can just select the type as Auth 2.0 one more time, and I can select the token. Here in the available tokens, I can click on manage tokens, and I can select this token and click on the use token button so that we can use that particular token when making this call. So I'm going to click on the send button now, and now you can see that we are getting the order placed successfully as a response. That's perfect. So both our product service and order service are now accessible through Keycloak. So the next thing we are going to do is to try to access Eureka from the browser. So, and let's see how is this going to behave, right? So I'm going to create a new browser tab, and I'm going to type in HTTP localhost 8080/eureka/web, you can see that we are getting a 401 error. So to fix this, we have to enable some kind of authentication also on our discovery server. So we cannot use the authentication mechanism with the token because, as you may have already observed, previously we are trying to contact our product service and the order service through the Postman client. Now we have to contact the Eureka discovery server through the browser, right? We cannot send the token, we cannot change the request through the browser and send the token manually, right? So for this, we need to enable basic auth in discovery server so that we can provide the username and password while accessing this discovery server URL. So for that, I'm going to open my IDE and I'm going to go to the discovery server, pom.xml, and I'm going to add the dependency with group ID org spring framework.boot. And here for the artifact ID, I'm going to type in Spring Boot Starter Security. Similar to the previous dependencies, I'm going to remove the version because I want to download it from the parent. Let's force IntelliJ to download the dependencies by clicking on the Maven icon. And now finally, I can create the security config class inside our discovery server. So for that, I'm going to open source main Java and I'm going to create the security config class by typing config.security_config. Now I'm going to add the configuration and enable web security annotation on top of the security config class. And the security config class is going to extend the web security configurer adapter class because now we are using Spring MVC. So for Spring MVC security, we can make use of web security configurer adapter class instead of the classes from Webflux. So this class now should override a method called as configure. So I'm going to type in override public void configure, and this is going to take a method parameter of type authentication manager builder. Let's also create the reference variable of this authentication manager builder, and inside this authentication manager and inside this method, I'm going to type in authentication manager builder dot in memory authentication with user as Eureka and dot password as password, and I'm going to add a basic authorities called as user. So we are just going to rely on the in-memory authentication for the discovery server. So that's why I added the in-memory authentication scheme. That's me also, we have an error here because this method is going to throw a exception. So let's add this exception to the method signature. So now we have a basic auth created in our security config. So let's add some additional configuration to our class. So by overriding another configure method, so I'm going to type in at override public void configure, and this time I'm going to add the method parameter as HTTP security, and inside this configure method I'm going to configure a basic security a default security details like HTTP security .csrf .disable and authorize requests .any request and authenticated. And lastly, I'm going to add the HTTP basic authentication because enable the HTTP basic auth, and also the CSRF method is going to throw an exception. Let's add this exception to the method signature, and now we have a basic security configuration with basic auth enabled, and this basic auth we are going to rely on a in-memory authentication, right? And one thing I don't like here is we are trying to hard code this username and password inside our code. So what we can do is we can externalize these properties to the properties file. So what I'm going to do is I'm going to open the resources application.properties, and I'm going to type create two properties called as eureka.username. It's going to be Eureka, and eureka.password is going to be password, right? I can also try to generalize this a bit more, and I can try to access this Eureka username and try to send this Eureka username and password through the environment variables. So for that I can type $Eureka_username is going to be username Eureka_password. So in this way, if we have configured the Eureka username and password as environment variables, we can just pass it while running the discovery server, and this will be picked up at the time of startup. And now inside the security config class, I'm just going to remove this Eureka and password, the hard-coded strings, and I'm going to make use of the values which we have configured in the properties file. So for that, I can use the value annotation to read these properties. So I'm going to type in $eureka.username, and this is going to be stored inside a variable called as username. And again, I'm going to copy this full configuration to the next line and define the field for the password called as eureka.password, and I'm going to rename this variable as password. Let's use this username and password inside the in-memory authentication configuration. So for the with user method, I'm going to provide the username, and for password method, I'm going to provide the password field as a method parameter. So, and lastly, we also have to define a password encoder whenever we want to define a username and password. So for that, after the in-memory authentication method, I can type in with .password encoder. And for this case, for this use case, I'm going to go with the no-op password encoder. No-op password encoder. This is deprecated, but just to make the demo purpose easier, I'm going to make use of no-op password encoder. But in the production, you have to not use this no-op password encoder. As this is for demo purposes, I'm using this, but I strongly suggest you to use a password encoder like a bcrypt password encoder or some other strong password encoders in your production code. Please don't use this, because I'm not using bcrypt password encoder because this needs some more configuration in the project, and that feels like diverting the actual goal of this project, because I want to show you how the microservices project works together, and I don't want to go in more depth than what I'm covering. So that's why I'm not covering how to configure bcrypt password encoder here, but I will leave a link down in the description if you're interested how to configure bcrypt password encoder. I will leave a blog link where I found, so that you can have a look at it and understand how to configure bcrypt password encoder. So moving ahead, I'm going to create the no-op password encoder, and I'm going to type the method .getInstance, so that we will get a basic no-op password encoder. So this is nothing but your password will not be encoded, it will just be displayed in plain text, right? So that's why this is not recommended, but for demo purposes, as I said before, I'm going to use this. So let's move forward. What I'm going to do now is restart the discovery server application. So now let's open the discovery server application. So I'm going to rerun my application in debug mode, and now I'm also going to, so once this is up and running, so without any errors, yes, it's able to start without any errors, I'm going to restart all my other services, thus all applications and the API gateway application in debug mode one more time. Order service, for example, is not able to reach the discovery server because we have enabled authentication. So what we have to do is we have to provide the username and password inside the discovery server URL, right? So for example, if I open the application.properties of API gateway, we have our Eureka client service URL default zone. This is pointing to the URL of Eureka dashboard. So what I'm going to do here is I'm going to add the username and password information as part of the URL. So I'm going to type in Eureka password at localhost 8761/Eureka. Right? So this is similar to the JDBC URL scheme, providing the username and password as part of the URL. So I'm going to add the same configuration also to our other services. So let's copy the whole property key value pair and replace it in all our services. So I'm going to open our inventory service, application.properties, replace this property. And similarly, I'm going to do this for order service and as well as the product service. So now I've configured the URL in all our services. So let's try to restart all our services and see whether we are able to start these services without any errors. Alright, so now you can see the order service is started without any errors. That means our order service is able to access the discovery server through the basic auth scheme. That's very good. So now let's try to access HTTP localhost 8761, and you can see that it is prompting us for the username and password. So let's try to type Eureka and password as our credentials and sign in. And now you can see that we are able to access our discovery server through the basic auth. And here you can also see that our dashboard is showing us all our services as we are expecting. So that's it for this part, guys. So in the next part, I'm going to discuss about the next component in our microservices called a circuit breaker. And we are also going to integrate the OpenFind client. We are going to replace the web client with OpenFind client. So I will see you in the next part. And until then, happy coding techies.